to you yet, whenever we talk about these things, you'll notice that I kind of keep bringing up the same type of information. We tend to have these 5 things. A starting velocity, which I'll refer to for the time being as the initial velocity. A final velocity. An acceleration, a time interval, and a displacement. These 5 things keep showing up in all of these problems. I keep bringing them up, they keep showing up. So I want you to start thinking and looking for these 5 things. In the problem I just gave you, I told you that the car started at 10 meters per second. And that over a time of 6 seconds, its velocity changed to negative 20 meters per second. Now, all I'm doing is kind of writing these things down, but these are the 5 things that tend to be showing up. Any question about where any of that came from? All right. So the next step would be to, kind of do what I asked here and make a graph. So I'm going to make a quick graph. And I'm going from 10 to negative 20. So I can shift that horizontal axis up a little bit to kind of accommodate the fact that I'm going to be going more on the negative side than the positive side. So out here, 6. Here, velocity. And here, time. I'm going to go up to 10 because that's where it starts. And I want to use even increments. So down there is going to be negative 10 and negative 20. Now, I looked at a lot of papers. I have people who couldn't do this. Do you have questions about why I set any of this up the way I did? You guys at home? Now, I'm doing this to the velocity graph because it was the velocity graph that gave me the information. I got all the stuff about velocity, so that's why I'm setting this one up first. I have no information about how far the object went, which is why I'm not starting with the position graph. The fact that I was told that the velocity changes in a uniform way is kind of it's a bit of a crutch. It's letting me know that although I started at positive 10 and I'm ending over here at negative 20, that the way in which I want to connect those two is with a straight line. That's what the uniform change is meaning, that this should be connected with a straight line. Now, even before I had that straight line, I could have figured out the slope of that line. Just from rise over run. I knew that I had to go from positive 10 to negative 20, a change of negative 30 meters per second. And I had to do so in 6 seconds. So, as a slope goes, it would have been negative 5 meters per second per second. If you look at that cheat sheet that I just started making for you, like the one I just said in class, the 3 things that you can get. The slope of the velocity graph is the acceleration. So I was telling you the acceleration. Not directly, I was telling you indirectly. Questions at home? Now, I'm going to erase the stuff that's on the graph, just get out of the way. But write this back in here, negative 5 meters per second per second. I also told you that the area under the curve would tell you the displacement. And earlier in the week, I indicated that you could treat this whole thing as one big trapezoid. And I stand by that. which means 1/2 the sum of the bases times the height. So base 1 is right here. That's 10. Base 2 is right here. That's negative 20. And this is the height. It's 6. That means over the entire 6 seconds, the displacement is negative 30 meters. That's where it ends up. Negative 30 meters. That might not be enough to make the next graph. But it is enough for us to know what the displacement is, negative 30 meters. I'm bringing it up because this is the important part. Solving problems using motion variables is something you will have to be able to do. I don't want to have to use a graph every time, but it's something I want you to be able to do. However, to make the position graph, you might need to know more things. Clearly, the object went forwards first and then backwards. It would be nice to know what this point is. When did it stop? It would be nice to know how far forwards it went before it turned around and started to go backwards. Those are other things you can get from the graph. And I'm expecting you guys to be able to do this. It went forwards 10 meters. 1/2 base times height. I got that because this has to be 2 seconds. I used the slope. The slope tells me it's going to take 2 seconds for that 10 meters per second to go to 0. Any question about where I got those things from? Well, this side, then, if I keep doing that, it's got to be negative 40. It went forwards 10, backwards 40, which is why it ends up at negative 30. Now I believe I have enough information to draw that position graph. When drawing this position graph, I need more negative than I have positive, so I'm going to draw the position graph in such a way as to provide me with more space on the negative side than the positive side. I want to see you anticipate those things and do this ahead of time. You're choosing the axes. Put my units in, put my labels in, and of course, 6 seconds, 2 seconds. The object has to go up to 10, so my units are going to be about that size. So 10, 20, 30. If the object starts at the origin, after 2 seconds, it is 10 meters away from the origin. And after 6 seconds, it's 30 meters away from the origin. A lot of you put 40 here because this displacement was 40. But it goes 40 meters from the 10 meter mark. On your quiz, a ton of people did that yesterday. The last step, draw the curve in. It has a positive slope here of 10. It has no slope here. And it has a steep negative slope here, negative 20. And then connect them. Well, I didn't connect them great, but that's going to be what it is. Look, I don't want to be doing the graphs that much, at least not that much more. I want you to be able to get this information without the graphs. In fact, that's your next goal. Here, I'm going to tell you the problem. I'm going to pick on 2 of you to speak to the class on this problem. I don't care how you find your answer. Ready? I'm at the top of a very tall building. Again, I'm at the top of a very tall building. I drop a ball. The ball accelerates downwards at 10 meters per second per second. After 5 seconds, how far has the ball fallen? There, I've kind of repeated all the information I gave you.
Final position was downward 125.
Okay, so Katie says the final position was downwards 125 meters. So, Aramis at home, would you agree with that or disagree with that?
The placement is downwards, so negative 125.
All right, so both of you have the number 125. So before I go any further and handle the discussion about negative or downward or whatever the right answer is supposed to be there, how did you come to the conclusion of 125?
I found the area of the triangle.
Okay, so still using kind of a sketch of a graph. You use the area of a triangle, and I know what your paper says because I was over there. So, would you agree that your sketch looks something like that? Is that about it? With this labeled as 5 seconds, and what was this velocity here?
Was the origin.
Start at the origin, sure, and went to what speed?
It went down to negative 50.
Okay, so negative 50. So your graph probably looks the opposite of that.
Oh, sorry.
That's okay.
What is the...
I agree. I never dimmed the lights. So we will have to do this. Let's just actually tell you what, because we're going to run out of time. I'll just make that negative 50. Fair enough? All right. So, and you did the area here. So you did 1/2 5 times negative 50 to get your negative 125. Let's handle the negative thing here because I don't want you to be confused by this. Downward doesn't have to be negative. Your choice of direction is an arbitrary choice. You have to apply it consistently, but it's an arbitrary choice. If you don't understand the word arbitrary, it means you can make this decision, and deciding positive or negative won't matter as long as you understand what positive and negative means. So if you've decided that downwards is negative, at the end, when your answer is negative 125, I don't want you to write negative 125. I would prefer you write 125 meters downwards, because that is better than blindly saying positive and negative. I guarantee you later this year, if you blindly apply positive and negative to what we're talking about, you lose a lot of information in that thing, and then you don't really know what you're talking about. So when you start a problem, especially one that's going to deal with these variables, assign positive or negative to a direction. And then at the end, when you're looking at that sign, decide what that sign is going to mean. The correct answer is 125 meters downwards. in the same way that its final velocity we found by happenstance to be 50 meters per second downward. Everybody follow along? This was a two-step process. I don't know if you saw that, but you had to find the final velocity first and then use that to find the displacement. I do not want every one of these problems to be a two-step process. I would like to show you shortcuts, ways where you can get your answers immediately. I don't want you to always have to rely on a graph. To do this is going to require that you have a little bit of abstract thought. I don't know if you have abstract thought. Some of you are still struggling just barely to get to this. But I can't do this for very much longer without me going crazy. So I want to show you an abstraction. We are going to run out of time, so I won't get very far. But I want to show you what I mean by say an abstraction. And I would really encourage you to put this into your notes. This is any object's motion. I am making a random graph that is any object's motion. I know that this particular look suggests it has a negative velocity first and then a positive velocity, but I had to draw something. But you do understand that I could start the object with any initial velocity and end it with any initial velocity. Right? That part is pretty clear? I don't want to put numbers on this. I want you to recognize that this is the initial velocity. That this is the final velocity. And that this is the time. Now I have to stop here because the bell rang. But we were going to pick this up right here tomorrow and then we're going to do our lab. Guys at home, you okay? All right, see you all tomorrow. Chloe, are you asking a question? Bye guys, have a good day. Hold on just 1 second, Chloe. Okay, go ahead.
Is there any like a place I could do more practice with these graphs to become more proficient in them?
I could give you some practice if you'd like.
That would be great if you could.
Okay, I will post some practice today during my lunchtime.
Thank you, Mr. Shelton. Have a good day.
Welcome, you have a great day too. Bye, have a nice day. Can you turn on the lights for me, please? Thank you.